This video is going to talk about graphing tangent. So this is 4.6 part 1. In 4.6 we'll be looking at all the different functions that we haven't graphed yet, but today's focus will just be tangent of x. Let's go ahead and just take a look at the basic tangent graph. And so you can see I have multiple periods of tangent graphed here. And we'll just focus for now right at the first one in the middle. So take a look at a few different things. The first thing is you'll notice that the tangent graph crosses the point 0, 0. And if you think about the tangent on your unit circle, at the point 0, the x and the y value is 1, 0. So when I'm finding tangent, I would do y divided by x, which is where that 0 comes from. Now, from there, if you continue around the unit circle, when we get over to pi over 4, which would be right over here in the middle, the tangent of pi over 4 is 1, so you can see why there's the 1 there. And then when we get to pi over 2, remember the point pi over 2 is 0, 1, and tangent of that is 1 divided by 0, which is undefined. Now because the tangent of pi over 2 is undefined, we end up with this vertical asymptote here at pi over 2. As we repeat around the unit circle, when I get to 3 pi over 4, we're down at negative 1. And when we get to pi, we're back to 0, the same pattern. And then 5 pi over 4 would get us up to positive 1. And then 3 pi over 2, once again, is undefined. And hopefully you can start to see this pattern that's happening. And so because of that, tangent gets these little tiny squiggles inside of 2 vertical asymptotes. And so it kind of can repeat over and over and over again. And then you can also go backwards. Now, because of that, tangent has 2 vertical asymptotes, and we'll use those to help us make the graphs. Looking at the characteristics, remember that the period of tangent is pi, and as you can see in the graph shown up top, that the graph repeats over and over again every pi units. Those vertical asymptotes happen at all of the odd multiples of pi over 2. So let's go ahead and list out where some of these vertical asymptotes will be. We've got negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on. If you'll notice looking at this that our x-intercepts, they happen right in the middle, halfway between those vertical asymptotes. So halfway between your vertical asymptotes. And notice that in this case, those are zeros and pi's. So we've got negative 2 pi, pi, negative pi, 0, pi, 2 pi, and so on. And those are all of our x-intercepts. Now in terms of the domain, we're going to have everything except where those VAs are. So we'll say all numbers except our odd multiples of pi over 2. And finally, in terms of our range, we've got negative infinity to infinity, so we've got all numbers. Now, if we take a look up at this graph just at the top for a minute, I'm going to erase what I have there just so we can see it a little bit better. If I want to graph different variations of this, a few things to pay special attention to. The first is that we have our VAs at negative pi over 2 right now and pi over 2. Now, what will affect those would be the B value, meaning the period change, and also the shift left and right. Halfway between those, we'll have our x-intercept. And then from there, we'll follow our amplitude up and down in the middle again, and we'll go up our amplitude 1, in the middle again, and down our amplitude of 1. And you can see that we've got our tangent graph. So when we're thinking about the 5-point method that we use to graph sine and cosine, we can have a similar 5-point method here. The first point we're going to be looking at are the vertical asymptotes. The second point then is going to be our middle, which will give us the x-intercepts. Finally, from there, we'll find middles again, and that'll be our amp up and down. And from there, we'll get our tangent graph. And so that's kind of the method we're going to use to graph these. Now, the hardest part to this is how to find the asymptotes, your vertical asymptotes, because you have to take into account the period change and the shift left and right. So let's look at a nice process that we have to do that. So taking a look at how to find the vertical asymptotes, we can go ahead and first notice that we have the similar general equation to our sine and cosine. And you'll see here that in this case, I left the b value inside the parentheses. That will be key. Now, what we'll do to find our vertical asymptotes is take that bx minus h and set it equal to our first asymptote, pi over 2, and our second asymptote, negative pi over 2. We'll solve both of those equations for x. That answer will be our vertical asymptotes. Let's just take a look at how to find those. So here's an example we'll use. Y equals 2 times the tangent of 3x. So again, the process we said is to take the thing, the bx minus h, the thing that you're taking the tangent of. So in this case, it's just 3x. And we're going to set it equal to pi over 2, and we'll also set it equal to negative pi over 2. And we'll solve both of these equations. In this case, I'm going to divide by 3. Now dividing by the 3, remember, is the same thing as multiplying by 1/3. And so we get pi over 6. Pi over 6 will be one location of a vertical asymptote. Doing the same thing on the other side, dividing by 3 is multiplying by 1/3, and we'll get negative pi over 6. And that would be the location of my other vertical asymptote. And again, this is just for one period of the graph. Once I have those, then I can make my graph. So go ahead, and your free response question is to try that. So the same thing, but for 2 tan 4x, and you'll enter those into your Google form. So now let's actually graph. We have 2 tan x over 2, and now this for negative pi to 3 pi, that's just telling me that I want to make sure I graph enough periods of this that my graph goes all the way from negative pi and ends at 3 pi. So let's go ahead and go through our process. Now the first thing we're going to have to do is find our asymptotes, our first points. So let's go ahead and find those. In order to find our VAs, remember our vertical asymptotes, we will go ahead and take our equation, the thing that we're taking the tangent of. So in this case, it's x over 2. And we will set it equal to pi over 2. And we'll also set it equal to negative pi over 2. We're going to solve for x in both cases. I'm going to cross multiply this time because I have two fractions equal to each other. So we'll have 2x equals 2 pi. When I divide by 2, I get x equals pi there. On the other side, we'll have 2x equals negative 2 pi. Divide both sides by 2, and we'll have negative pi. Now, since that will be the location of my asymptotes, and I know I'm going to have to plot a point in the middle of those, let's go ahead and scale our axes, just maybe in terms of pi over 2's. So we'll start at pi over 2, pi, and so on. 3 pi over 2. I'm going to go all the way to 3 pi because that's where I want my graph to end. And we'll do the same thing in the negative direction to negative pi because that's where I want that graph to end on that side. So now that I have my axes scaled, I think our amplitude was 2, so we'll go up 2 and down 2. We're ready to go. So the first thing we want to do is plot those asymptotes. So remember we said those will be at pi and negative pi. So I'm going to go to pi and draw in a VA and negative pi and draw in a VA. And I graphed those backwards than I said them. And I can follow the same pattern if I want, so it looks like there's 4 tick marks in between. So the next one will be at 3 pi. And now I can make my tangent graph. So the first point would be the asymptotes. The next point will be directly in the middle. So directly in the middle is 0, and that's going to be your x-intercept. From there, at pi over 2, remember you'll go to the right in the middle at pi over 2, and you'll go up the amplitude. And you'll go to the left in the middle and go down the amplitude. And then So now let's go ahead. And we've got our first period. We'll repeat the same thing in the second set. So 2 pi will be our intercept. At 5 pi over 2, we'll go up 2. And at 3 pi over 2, we'll go down 2. And again, we'll get the second part of our graph there. And there is our final product. Let's take a look at one last example. So we have the tangent of x plus pi over 4. The same process, we'll start by finding our vertical asymptotes. Now again, you're going to take the thing that you're taking the tangent of, so the x plus pi over 4, and set it equal to pi over 2, and once again, x plus pi over 4, and set it equal to negative pi over 2. Now in this case, I'm going to subtract pi over 4 from both sides, because I'm trying to solve for x. We're going to need some common denominators here, so I'm going to change pi over 2 to be 2 pi over 4. And now when I subtract those, we'll get negative, 2 pi over 4 minus pi over 4 is just pi over 4. Same thing on this side. And again, common denominators. And it looks like in this case, we'll end up with negative 3 pi over 4 as our other vertical asymptote. So those VAs in this case were at pi over 4 and also at negative 3 pi over 4. Now that we have those, I'm just going to get this out of the way here. We can go ahead and make our graph. So what we'll do now is start by scaling the axes. I'm just going to start off by scaling in terms of pi over 4. And there's no limit here as to how much or how little we need, so we'll just start by going backwards. Negative pi over 2 would be next, and finally negative 3 pi over 4, which is good because an asymptote will go there. We'll need 1 pi over 4 for sure. And let's go one more time through just so that we can get 2 nice periods of this graph shown. We'll go one more. Let's see, 5 pi over 4. And it looks like our amp in this case is still just 1. So remember, the first thing to do is to plot your vertical asymptotes. So we've got negative 3 pi over 4 and 1 pi over 4. And if I continue, the other one will be at 5 pi over 4. We will plot the middle of those 2 points, and in this case it is negative pi over 4, and that'll be our x-intercept. We'll go halfway, which is 0, and go up to 1, and halfway again and go down 1. And then there's our equation, our graph. And we'll repeat the same thing again to get the second period of it. And there's our finished product. So here's a multiple choice question for you to try. You're matching, and when you are done, you can put that answer into your Google form. And that's where we'll end today.